End of chapter exercise. First question. So what are the x coordinate and y coordinate of the point of intersection of the two axes? This is the point of intersection where the x coordinate and y coordinate. Now, for example, this diagram you can take it as this is x-axis and y-axis. Both the axes are intersecting at origin. Okay, so you can just write it as origin. Okay, origin. So the origin coordinate is 0, 0. Now the second question, point W has x coordinate equal to -5. Okay, x coordinate equal to -5. How to draw the graph for x is equal to -5? X coordinate is equal to -5 means actually x is equal to -5. So we have to draw the graph for this. How to draw the graph? First you draw x-axis and y-axis. Okay, x is equal to -5 means just draw the line on x is equal to 5. Now this is x is equal to 5. So draw the line. So it will be parallel to y-axis. X is equal to -5 means so draw a line on x is equal to 5. Now, so can you predict the coordinate of the point H which is on the line? Okay, we have to take one more point H. That is also should be on the line W parallel to the y-axis. Which quadrant can H lies? Now we have to take one point H. Okay, we have to take the point H. That is should be on the line W. Actually, this is W line. We have to take one point H. This should be on W. Okay, what are the possibility quadrant of the point H lies? H lie on, okay, H lie in either second quadrant, second or third quadrant, second or third quadrant. Third one, consider the point R 3, 0 and A 0, -2, M -5, -2, P -5, 2. If they are joined in the same order, predict two sides of ramp that are perpendicular to each other. First, I'll just mark the point R 3, 0. Now this is 3, 0. This is my R. Next 0, -2, 0, -2. Now this is A. Next -5, -2, -5, -2. This is -5, -2. This is M. Next -5, 2, -5, 2. Okay, this is P. So now I have to join the points. Okay, joining in order. Okay, R A M P. Okay, this is R A M P. R A M P. So I have joined the points, right? So I am getting R A M P. It's like a quadrilateral. Now we have to answer the question. Two sides of ramp that are perpendicular to each other. Okay, which two lines are perpendicular to each other? Two sides ramp that are perpendicular to each other means so PM and MA. So this is forming 90 degree. These two lines are perpendicular. Now second question, one side of ramp that is parallel to one of the axes. So now here PM is parallel to y-axis. So this line PM is parallel to y-axis, or we can say MA. Okay, that is MA or AM is parallel to x-axis. That also we can write. Like third question, two points that are mirror image of each other in one axis. Which axis will this be? Okay, now plot the point and verify your prediction. Okay, so now 2 points are the mirror image on one of the axis. Which axis will be? So mirror image means that should be opposite. If you are just placing the mirror here, if you are just placing the mirror, that should be divided into exactly equal half. We can just say. Or if you are folding this P, that should exactly coming to the M. Okay, what are the 2 points? P and M are mirror image. So let me show the answer here. So first one they asked, okay, the perpendicular, we can just write it as PM is perpendicular to MA. Why? Because this is forming 90 degrees. So now this is the answer for first one. Second, they are asking parallel. Okay, PM is vertical, that is parallel to y-axis. So PM is parallel to y-axis. The same as MA is parallel to x-axis. Now this is the answer for second one. Third one, they are asking mirror image. That is P is mirror image of M. So P and M are mirror image. So now this is the answer for third one. Right. So we're just moving on to the next question. Fourth one. Okay, plot the point Z 5, minus 6 on the Cartesian plane. Construct a right angle triangle IZN and find the length of the other three sides. Okay, only one point is given. Okay, Z is equal to 5, minus 6. Okay, 5, minus 6. So now this is my 5, minus 6. Okay, only this is Z. I have to make other 2 points so that I'll be getting a triangle. Okay, so after getting the triangle, we have to find out the length of other 2 sides. Okay, so let me, this is one side is given, right? I have to find out right angle triangle. So right angle triangle means one of the sides should be 90 degree, right? So I can just mark, right? Okay, many different way you can just form the right angle triangle. This is one of the way. Okay, according to my answer, I'll just form the right angle triangle. Okay, only one point is given, correct? One point is given. Okay, so for forming the right angle triangle, one angle should be 90 degree. Okay, we need 3 points. They have given only 1 point, that is Z alone is given. 5, minus 6. This is my 5, minus 6. Okay, now I have to find out 2 more points. So I have taken the point, the 3 points are, one is 5, minus 6. Second one, and I am just taking as 2, minus 6. That is 2, minus 6. That is 2, minus 6. I mean, this is 2, minus 6. And another point I have taken as N as 5, minus 2. 5, minus 2. Now, so I have taken the point that this is Z is already given. Now this is 2, minus 6. This is I. And this is my N. If I just join all the points, I'm just getting, okay, right angle triangle. So just join. So I'm just getting a right angle triangle IZN. So the answer may be vary. They have given right answer may differ from person to person. If you are taking small right angle triangle, answer will be differ. If you are taking in the beginning, we have taken big triangle. So the answer may be differ. Now, so we have to find out the length of the 3 sides. So length we have to find out. So what is the length, right? So length of this side. So how many units? Here this is 1, 2, 3. Okay, 3 units. And here how many units? 1, 2, 3, 4. Okay, 4 units. Now we have to find out this side. Okay, so this side we cannot count how much. Now this is 3 units, this is 4 units. Now this is a right angle triangle. We have to use only Pythagoras theorem to find out the third side. Okay, for finding the third side, that is IN, I can use the Pythagoras theorem, right? Now first you can just write what are the sides I got, right? IZ. Okay, IZ is equal to 3 units. Next, okay, NZ. Okay, NZ is equal to 4 units. That is by counting, you can just get by the graph. Now I have to find out, okay, IN. Okay, to find IN, so we have to use the Pythagoras theorem. To find IN, use Pythagorean say, okay, Pythagoras property or Pythagoras theorem. Okay, okay. So using the Pythagoras property means IN square. Okay, IN square is equal to 3 square plus 4 square. Okay, 3 square is 9 plus 4 square is 16. Right, so IN square is equal to 9 plus 16 is 25. Okay, therefore IN alone take the square root of 25. Okay, square root of 25 is equal to 5. Therefore the length of IN, okay, IN is equal to 5 units. So why I have chosen this point means we are getting the length of the side is in whole number. Okay, if you are choosing the triangle in different way up to here length, and this is also right angle triangle, you may get the length in, okay, not a perfect square number. Okay, so you can draw different direction right angle triangle. For my convenience, for getting the whole number, I have choose these points, so that we are getting in is equal to 5 units. So now question number 5. So what would be the system of coordinates be like if we did not have a negative number? So would this system allow us to locate all the points on the two-dimensional plane? Once again, what would a system of coordinates be like if we did not have a negative number? That means we are having only the positive number. What would the system of coordinates? So that will be lying on first coordinate. Okay, first quadrant. Only positive means this should be lying on first quadrant. Second one is they are asking all the points, not only the positive points. Okay, only positive means it will be lies on only the first quadrant, right? They're asking, would this system allow us to locate all the points on the two-dimensional, including negative also? The answer is no. It would not allow us to locate all the points in the two-dimensional plane because we would not able to map anything to the left or below the origin. That means either second quadrant, third quadrant, or fourth quadrant. Okay, that is the answer. You don't need to get confused with so many things, right? So now next concept is collinear points or collinearity of 3 points. That is nothing but if the 3 points are lying in the same line. When we can say the 3 points are lying in the same line means, right, the distance between, distance between the two pairs is equal to the third pair of the points. When we can say the 3 points are collinear means, right, so we are going to check this condition. Okay, AB plus BC distance should be equal to the distance of AC. If this condition is satisfied, we can say the 3 points are lying on the same straight line. If the 3 points ABC are not collinear, they are forming a triangle. That means 3 points are not lying on the same line, it will form a triangle. That is non-collinear. This is one point. Okay. 2 points are in the line. Another point is not in the line means it will form a triangle. Okay, non-collinear. If it's collinear means the 3 points should be lies on the line. When we can just check, for how to check means we have to check the distance. Distance between AB plus BC should be equal to the distance of AC. Question number 6. Okay, now from 6th question onwards is the hard question, higher order thinking questions. Okay, they have given the star mark. Star mark means we will be applying 10th standard concept also. Okay, up to this you must understand everything, right? So after this you have to, you just try to understand. Are the points M, A, G are on the same straight line? Suggest a method to check out without plotting and joining the points. Okay, without the graph, you have to check the points M, A, G are lying on the same straight line. For this only, we are going to check the collinearity concept. When we can say the 3 points on the straight line means, right, the condition MA plus AG should be equal to MG. They are satisfying the condition. We can say these 3 points are lying on the same straight line. Otherwise, it's not lying on the same straight line. Okay, so now we'll just check it out whether they are lying on the same straight line. So 3 points. Okay, so for example, I can just take a line. So I'm just taking line. So I just take, this is M. Okay, this is A. And this is G. Okay, if they are lying on the same straight line, okay, if they are lying on the same straight line, the condition, okay, MA plus AG should be equal to the length of AG. Sorry, length of MG. Then we can say they are in the same straight line. Otherwise, it's not in the same straight line. So MA is nothing but the length of, that is the distance of MA, the distance of AG should be equal to the distance of MG. Now only you are going to apply the distance formula. Okay, distance formula. First, you can just find out the distance of MA. Okay, M is given as -3, -4. So A is given as 0, 0, and G is given as 6, 8. Okay, the distance of MA. Okay, MA distance. I'm going to find out the distance of MA. So you can use the distance formula. Okay, x2 minus x1 the whole square plus y2 minus y1 the whole square. But here one of the point is origin. Correct? So one of the point is origin. So directly I'm just going with the formula x square plus y square. Okay, origin formula x square plus y square. Okay, x square plus y square means, so -3 square. Okay, plus -4 square. Okay, -3 square is 9 plus -4 square is 16. Okay, 9 plus 16 is 25. Okay, now MA is equal to the square root of 25 is 5. Okay, MA is equal to 5. I am getting it. Next, I have to find out the distance of AG. AG distance. AG also one of the point is, okay, origin. So the same formula I can just go up x square plus y square. Okay, x square plus y square formula. Here x value you can just take it as 6, right? 6 square plus 8 square. 6 square is 36 plus 8 square is 64. Okay, 64 plus 36 is 100. Okay, this is 100. The square root of 100 is 10. Next, I have to check the distance of MG. Okay, MG distance. Okay, MG. So in MG, they are not in the origin. So we have to apply the distance formula. Okay, we have to apply the distance formula. So distance formula is x2 minus x1 the whole square plus y2 minus y1 the whole square. Actually, this is x1, y1, x2, y2. If you're having confusion, just make a note of it, right? Now, this is x1, y1, x2, y2. So, apply it in the formula. Okay. x2 means that is 6 minus in the formula. Again, x1 is -3. Okay. Now, the whole square. x2 minus x1 the whole square plus y2 8 minus again -4 the whole square. Just simplify it. 6. Okay, minus of minus is plus. 6 plus 3 the whole square plus 8 minus of minus is plus 4 the whole square is equal to 6 plus 3 is 9 the whole square plus 12 the whole square. Okay, 9 square is 81 plus 1 square is 144, 12 square. Okay, 81 plus 144 is, we are getting 225, 225. The square root of 225 is 15. Okay, 15. Now we have to check the condition. Okay, so now the condition MA plus AG. Just check MA plus AG. MA plus AG. So MA plus AG means 5 plus 10 is equal to 15. Okay, now MG is equal to 50. So MG also is coming as 50. Okay, therefore we can just write MA plus AG is equal to MG. This is satisfying the condition. Okay, this is satisfying the condition. Therefore, they are lying in the same straight line. Okay, therefore, these points. Okay, these points lying on the same straight line. You can just write therefore. Now question number 7. Use your method, okay, in problem number 6 to check if the point RBC are in the same straight line. Plot both set of points and check your answers. The same condition, right? So same collinearity we have to check. If they are satisfying the condition, they are lying on the same straight line. Otherwise, it's not lying on the same straight line. Then we have to plot the point and check your answer. First, I'm just taking the line, straight line. Now I can just take it. This is R. Okay, next point is B. Next one is C. If the 3 points are lying on the same straight line, the condition has to be checked, right? So R point is given -5, -1. Next one is -2, -5. Next is given 4, -12. Okay, now I have to check the condition. Okay, the condition is so RB. Okay, RB plus BC should be equal to the length of RC. This is the condition. Now I can just check the length of RB first. RB length, that is RB distance. So I have to apply the distance formula. Okay, distance formula. Okay, this is x1, y1, x2, y2. Okay, so the distance of RB, right? X2 minus x1 the whole square. For first alone, I'll just write the formula. X2 minus x1 the whole square plus y2 minus y1 the whole square. Right. So x2 minus x1, right? So just apply it in the formula. X2 is -2 in the formula, minus again here -5. Okay, so now the whole square plus y2 minus, okay, -5 again here we have minus of -1 the whole square. Okay, just simplify it. You'll be getting -2 minus of minus is plus 5 the whole square plus here -5 minus of minus is plus 1 the whole square. Okay, so -2 plus 5 is 3. Okay, 3 square plus -4. Okay, -4 the whole square. Now 3 square is 9 plus -4 square is 16. Okay, 9 plus 16 is 25. The square root of 25 is 5. Okay, now RB we are getting as 5. So next, the same way, you have to find out BC. Okay, BC. So BC we have to find out. While taking BC, we have to change the coordinates. Okay, now change the coordinate B and C. Okay, so B and C means, so just write this is x1, y1, x2, y2. So apply in the formula. I am just writing directly x2 minus x1 the whole square means so 4 minus of -2 the whole square, x2 minus x1 the whole square plus y2 minus 12, y2 minus y1. So minus of -5 the whole square. Okay, simplify it. So 4 minus of minus is plus 2 the whole square plus -12 minus of minus is plus 5 the whole square, right? So 4 plus 2 is 6. 4 plus 2 is 6. We have 6 square plus -12 plus 5 is we are getting -7. -7 the whole square. Okay. Now 6 square is 36 plus 7 square is 49. 36 plus 49. Okay, we are getting 85. Okay, root 85. So root 85 is not a perfect square. We cannot simplify further. So root 85. Now we have to check with RC. Okay, R and C. So we have to check the length of RC. Now the distance of R and C, if you are just proceeding, you will be getting 202. Okay, we are getting as 202. 2. This is also not a perfect square number. So now while adding, let's just check the condition, right? RB plus BC. Okay, RB plus BC. RB is equal to 5 plus BC is equal to root 85. We cannot add further, right? So this is the answer. Now RC is equal to root 202. Okay, so they are not equal. Okay, so RB plus BC is not equal to RC. Therefore, these points are not in the same line. Okay, therefore, these points not lie on the same line. Cannot lying on the straight line. Okay, hope it's clear. Now we have to check. Okay, they ask us to plot both the sets of the point and check your answers. Okay, check your answer. So let me plot quickly and I will just check the answer. Right. So now I can just plot. Okay, r is equal to minus 5 comma minus 1. Minus 5 comma minus 1. This is my minus 5 comma minus 1. Okay, this is r point. Next, minus 2 comma minus 5. Minus 2 comma minus 5. Now this is B point. Next, 4 comma minus 12. 4 comma minus 12. Okay, 4 comma minus 12. Correct now. 4 comma minus 12 means is coming here. Okay, exactly. Now I'll just check whether I am getting the straight line. Okay, so 1 point, okay, little is missing. Okay, therefore they are not lying on the same straight line. Okay, so we plotting the point easily identify. Without plotting the point means you have to check the condition. It's clear now for everyone?